Hello and welcome back to the video series for the Introduction to the Art of Programming using Scala. In the last video we started looking at the command line and basic commands for doing file manipulation. In this video we're going to continue talking about files, talking about the command line, but we're going to look at permissions and how you can do compression on the Linux command line. So if you go back to the Linux Mint environment, and once again we will pull up a terminal because that is the environment that we're working on at this point. We'll remind you about the ls command. So ls lists the files that are in a given directory. If you give it the -l option, it shows you a longer listing which has additional data in it, and then al gave you also hidden files, files that begin with a dot. And what we want to pay some attention to for this video is the first 10 characters over here. So for each of these files we have this basic information, and we went over what these things were, and right now we care about this. We'll also talk a little bit about this in here. These are permissions flags. Now the first thing is, here we have a D, here we have a blank. The D implies it is a directory, and in fact if you look you'll notice that everything that has a D is lined up with something that's in the blue, and those that do not are regular files that have the black coloring. So that is just another indicator of whether or not you have a directory. It's also possible to have link files, which we don't have here. After that are 9 letters that are grouped in threes. You see here we have an RWX, and then here is an R-X and an R-X. For this particular file, the second group also had a W in it. The question is, what do these things mean? Well, R, W, and X stand for read, write, and execute. So this implies that someone or some group has the ability to read the file, to write to the file, to alter it in some way, and to execute it. And so in the case of directories, if you want to be able to go into a directory, you have to execute it. The standard files, only executable files, should have that flag set. Now there are 3 groups here. The first group is for the owner of the file, and that is the first name that's listed here. There is a command, just in case you ever forget who you are, you can ask the command line, "Who am I?" and it will tell you. For this environment here, we are running as the user student. And that lines up with this here. If we had any files, so for example, if we look in the root directory, you'll notice that student does not own these files. These files are owned by the user root. Root is the name for the super user on Linux systems. The second group of letters, so this set of RWX, represents the group permissions, and you can see what groups you are in by typing in the command groups. As you can see, the default user that you have here is in quite a few different groups. This allows it to have the ability to actually run administrative types of commands with proper permissions. The first group is actually the name of the user itself. When you create a new user under Linux, you always get a group of that same name. And so in our basic directory, everything was owned by student, and it was part of group student. Now, if you have a group of people who are working on the same project, the way that you would deal with the permissions is that you would create a new group and make everyone who is working on that project part of that group. And then you'd want to make it so that that group has ownership of the file, and we'll talk about how we do that in just a second. But this second set is the permissions that are given to whatever group that you are in. And the last set is permissions that are given to everyone, okay, all the other users on the system. So, for example, the directory videos in here, any user on the system can go into it and they can look at its contents, but they're not allowed to modify it in any way. Whereas this file here, the user is allowed to read and write to it, but the group is not, and no one else can do anything to it. So each of these files has their own permissions. What if we wanted to limit the permissions? So what if we had a file and we didn't want everyone to be able to, for example, read our Scala history? If we wanted to do that, the command is called chmod. And remember from last time that you can use the man command to get a manual page for whatever it is that you want information on. Chmod changes the file permissions, and it turns out that this has a rather long page, and well, there are quite a few options that you can use with this. I am going to talk through the simpler set of permissions where you use letters to represent users, groups, others, and all, and setting permissions, and then the permissions using the letters, because I think that is easier to read. It's also possible to use to set things using bit flags, but that, since we haven't covered binary representation, would be a bit more challenging. So let's go back to that example of I want to make it so that the Scala history is not readable to everyone. So I would run the chmod command, and first I give it the group of people that I want to change permissions for. In this case, I want to change it for others. So U would be for the user, G would be for the group, O would be for others, and A would be for everyone. I want to change permissions for others, and you can use either plus if you wanted to give them permission. So for example, if I want everyone else to be able to write to it, I could say plus W. Minus if you want to remove a write, so this is what I'm actually going to wind up doing, subtracting off the reading permissions. And there is also an equals where you could just say, okay, well, make it so they only have write permissions but no read permissions. In this case, I am going to do that. And now if we look at the directory again, you can see that on Scala history there is no more read permission for other users on the system. If I were to go back, turns out that there's possible the Scala compiler wants the Scala history to be world readable, or maybe I realize I don't care, that people looking at my Scala history doesn't matter. I could give them back permissions, and once again we see that that read permission is in there. Why would you ever want to change permissions? Well, it's possible that files are created with more permissions than you want, so you don't want other people to be able to see things. It's also possible that you do want people to be able to see things. For example, a lot of times I have students who post things into a web space on our systems. Well, the web server can only see things that are world readable. So you have to give them the read permission for other users, as well as, if it's a directory, the execute permissions for it. If you create the file and it doesn't have those permissions, you have to go in and change the permissions on it. We mentioned earlier the fact that you might have some other group that you want a file to be owned by, a file or a directory. And the way that you do that is to run the chown command. So once again, you can look at the man page for this and feel free to read through it. The basic usage, you have some options in here, but after chown, you give it an owner and a group, and they are separated by a colon. If you leave out the colon, it assumes that the only thing that you've typed is the new owner for the file. If you want just a group and you don't want to change the owner, which is what we were describing, you would have colon followed by the group that you want, and then you list the files that you want to change. So in this case, if I wanted to, I don't actually have a group by this name, but let's say I had a group for the new project that I was working on, and I wanted the Scala history to be owned by that, I could run this. In this case, since I don't have that, I get back an error message saying that that group does not exist. It's also possible you might want to set an entire directory for both, either for the chmod, so you want to set permissions, give more permissions, not just to a single file, but to an entire directory and all the files underneath it, or you want to change ownership in that way. Both of these commands support an argument for going through and doing what's called recursive descent through all of the directories. That term is something that we will wind up using later on, and it will potentially make more sense then. So that gives you a basic understanding of permissions and how you can modify them. If you're only working in the virtual environment, because it's sitting here on your computer and you are a student and whatnot, you generally won't have too much of a problem, and you won't have to deal too much with permissions. Every so often you might decide that you want to make something executable, or you download new stuff to install and it needs to be made executable, and you'll have to run chmod in order to do that. Another thing that is potentially helpful for you to know, and this might be because your professor wants you to turn in a bunch of files as a single file, either through email or through some other form, you might need to know how to compress and archive things. And so there are a number of commands that you can use for these purposes. The primary archive command is a command called tar. And so we can man tar. The tar actually referred to tape archiving because this dates back to the time when a lot of the archiving on computers was done to tape drives, and if you had a whole bunch of separate files, you actually wanted to create one large file out of them most of the time. And that's the basic functionality that tar gives you. You have the ability to put multiple files in one file, or to extract multiple files from a single tar file. The usage has the command followed by a set of flags. There are many options. You can refer to the man pages for the various options for them. If you download a tar file and you want to extract it, and this is another reason why this might be useful to you, maybe you have some other program that you want to install that's doesn't have a standard installation set up, you might wind up downloading a gzip tarball, which is a standard way of distributing things for Linux. It would be inside of a compressed tar file, and to expand it back out, you would use X to pull all the files out. If you're pulling them from another file, you would say F, and then whatever the name of the file was. Now, a lot of times for distribution, these will be gzipped tarballs. Those will either end with a tar.gz or a tgz for short. And so if you want to pull those contents out, you could run the gzip and gunzip that we'll talk about in just a second, or you can put in a Z here, and this says, I want to run tar, I want to extract from a file, the file is zipped, and I'm going to give you the file name, and this is it. And then it will pull out everything that is in that gzip tarball and stick it in your current directory. If instead of actually expanding it, you just want to see, well, I don't know what's there, you can use the T option. This T option says just print out all the stuff that's in there. If you were creating a new tarball, you could use a C. So if you just say CF and then something like this would take all of the files star and tar them up into a file called tarball.tar. If we wanted to also have it be gzipped, we could do something like that. So there are a number of different usages that you can go look in the man page for more on them. We mentioned gzip. So if you're used to a Windows environment, you are probably used to zip files. They are a standard compression. There is a slightly different compression format that's often used in Linux called gzip. And these are not exactly the same. In fact, you'll notice there is a gzip and a gunzip. So when you want to compress something, you gzip it, and when you want to uncompress something that's been compressed, you use gunzip. When you put in that Z on the tar option, it winds up running the tar and either gzip or gunzip together to give you the files that you want or to give you a single compressed file format. If you happen to get a zip format, there is also a zip command that you can use, and this will allow you to this can be used with the -R to take an entire directory structure, whatnot, and zip it up. So here's an example usage: zip -R. This says to go down into all the files. You're going to stick them in a file called foo.zip, and you are zipping the entire contents of the foo directory. So this can be helpful. Sometimes you will need to unzip files. And there is an unzip command that will let you do that. So if you've downloaded something and it was not in a gzip tarball, but it was in a zip file, you can unzip it using the unzip command as well. So that covers the basics of permissions, how you can modify permissions, how you can tell what you or others are allowed to do with a file, as well as basic commands for doing compression and for creating single large files. Once again, your instructor might want you to turn in things either as gzip tarballs or as a single zip file when you have multiple files that need to be submitted all at once, as opposed to, say, attaching 10 files onto an email, which can be kind of unwieldy to work with. So that's it for this video, and hopefully we'll see you soon.